Welcome to another math problem of the week. Positive integer n with at least 4 factors. Sum of square of its factors. Let's talk about it. For today's question, it's actually come from SMO Junior 2018 round 2 question. This is a number theory question, and we are asked to determine all positive integer n with at least 4 factors such that n is the sum of the square of its 4 smallest factors. So we modify a little bit according to the purpose of problem of the week. Find the number of such positive integer n. So the option can be A, 1, B, 2, C, 3, and D, 4. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
To understand the question better, let's deal with some number n. Let's say, for example, if n equals to 24, then we know that this is 2 to the power of 3 times 3 to the power 1. If we fulfill this condition, the sum of square of its 4 smallest factors. What are the factors of 24? It is 1, 2, 3, 4, 6, and so on. The 4 smallest factors are 1, 2, 3, 4. The sum of square of 1, 2, 3, 4, it will be equal to 1 square, 2 square, 3 square, and 4 square. And this is equal to 1, 4, 9, 16. And it's turned out that this is equal to 30. Unfortunately, 30 is not equal to the n itself. So this is not the n that we want to find. With this example, I hope that you have a better understanding of the question itself. Let's try it rigorous now. It says that in this case, n is a sum of square of 4 smaller factors. So n has to be equal to n has to be of this form, where each of these is the factors of n, and they are the smallest among the rest. Obviously, 1 will be a factors of n. Now we just need to consider some of the cases where we have even factors and odd factors. There must be at least one odd number among these. And if it's 1 odd, then it will be 3 even. 2 odd, 2 even. 3 odd, 1 even. 4 odd, 0 even. Suppose that there's only 1 odd and the rest are even. So what does it mean? It will mean that n has 1 odd number and 3 even number. We'll consider number modulo 2. And this will mean that n is congruent to 1 mod 2. n is an odd number in this case. If n is an odd number, then it cannot have an even factor. And this will be a contradiction. And therefore, this is not possible. And we'll do the same thing for this one. 1 even and 3 odd. Also will give you n as an odd number with even factor. Again, this is a contradiction. And for this case, n will be congruent to 1 plus 1 plus 1 plus 1 mod 2. And it will be congruent to 0 mod 2. Then, in this case, n will be an even number. If n is an even number, then 2 has to be one of the factors of n. And 2 is a number after 1. So 2 must be one of the smallest factors. And it will contradict to this again. And therefore, this case also not possible. It turns out that this is the only possible case where out of 4 smallest factors of n, 2 of them are even and 2 of them are odd. And since 2 of them are even, the number 2 has to be one of the smallest factors. So this will be 2. And let's say this is A and B, when one of them is even and one of them is odd. Now we consider this case. We will make a claim that none of a and b equals to 4. Suppose not, let a equals to 4, and this is n. Now in this case, b is an odd number. Now we will consider this number modulo 4, and we will see that 2 squared is 4, that's why it is 0 congruent 4, and 4 squared is 0 congruent 4, and this is 1, and this is b squared. Since b is an odd number, then it means that b must be either equal to plus or minus 1 mod 4. If that's the case, b squared has to be congruent to 1 mod 4. So this means that n will be congruent to 1, and 1 is congruent to 2 mod 4. And this will be a contradiction again, because n is equal to 2k, so n squared will be 2k squared, and that will be congruent to 0 mod 4. And therefore, n congruent to 2 mod 4 is a contradiction. None of the AB is equal to 4. Let me write the result here. Suppose P is the smallest odd prime factors of n, and we claim that 2p must be among the 4 smallest factors of n. Then n will be equal to 1 squared, 2 squared, p squared, and 2p squared. Suppose this is not true. Out of these 3 smallest factors, let's say we have another factors in between 2 and p. If 2q is one among the 4 smallest factors, where q is a prime number, then we will see that q will be another odd prime factors of n. That will contradict to the assumption of p is the smallest odd factors of n. If q is not an odd factors, then eventually 4 smaller factors of n, in which case it will bring you a contradiction. So you won't have anything here. How about we have some factors that is greater than p but less than 2p. Now again, if this is an even number, it is not possible of the reason that we have said before. And this factor cannot be an odd factor because you need to have 2 odd factors and 2 even factors. And this concludes that n has to be of this form. Then we will see that n can be written as 5 plus 5p squared. P divides n, and p divides p squared, and therefore p must divide 5. If p divides 5, then it means that p is either 1 or 5, but it cannot be 1, and therefore it has to be 5. Since p equals to 5, then n is equal to 5 plus 5p squared, and this is equal to 5 plus 125, that is 130. And n equals to 130 is the only positive integer n with this property. Let's check that what are the factors of n. N obviously have a factor of 1, 2, there's no 3, there's no 4, there is a 5, and 10. We verify that n equals to 130 is the only answer for this question. Personally, I feel that this is a very interesting question. We can get the answer by considering bit by bit. It's not very difficult, but it's rather interesting. This is end of the lesson. I'll see you again. Bye-bye.